Hello students, you are welcome back to the channel. Get understand, don't memorize. This is the continuation of the series of lessons on the topic of sets. Continuation of the series of lessons on the topic of sets. So let us continue. Let us continue. In the previous lesson or video, we looked at the properties or the rules or the laws of sets. Properties of sets or the rules of sets or the laws of sets. They are the same thing. They mean the same thing. And then when you talk about the properties of sets, what do we mean? You looked at it means that the different ways in which sets can be written or can be represented, and if they are written in those form, how are we to handle them or manipulate them? Yes. So that is what the whole thing is what it's about. So it's about how sets can be written in the various form in which sets can be written and how are they manipulated. So for example, uh, we had this example, square root of a over square root of b, where a and b are rational numbers. So we are saying that sets can be written in this form. So if they are written in this form, what do they mean? Their meaning. And how can we manipulate them or simplify them or handle them? So the properties just give us or the rules, the laws. That if you have a set, if they are written in a particular form, how are you supposed to handle them? How can they be manipulated? That is what the properties mean, or the laws, the rules. So if you say rules or laws, I think intuitively, you know that is how you should go about it, how you should handle or manipulate the sets. So if we have this, we know that we said that what this one we can write it as what a over b and put them under what one square root sign. And also if you have what a b, which means that a and b, you said that if you have this, so this a set can be written in this form. So if you have a set in this form, what does it mean? It means that this a is what multiplying the b, and they are put what under this one square root sign. So if you have this, how can we manipulate? How can we handle this? So we learned that we can separate this and put each one of them in what in the square root under the square root sign. Have you seen? So that is what you mean. This is a recap of the properties of sets, or the what do you call it, the laws or the rules of sets. So they just give us the various ways in which what sets can be written, and if they are written in those ways, in those form, what do they mean? What do they mean? The set written in those form or given in those form, what is the meaning of that, and how can we manipulate them? How can we handle them? So in fact, this what do you call this, properties of sets or rules of sets are laws of sets, but they are the main pivot around which this topic of set will revolve. Because if we start solving questions, start solving final exam questions and examples and exercises, this we are going to apply these properties in handling and manipulating the questions, the exam questions, the exercises, the example that will be given. So that is what we mean. So in this video we are looking at what, how to simplify hot sets or simplification of hot sets. In other words, we are also looking at reduction of set to the basic or its basic form, or to its simplest form. How can we reduce a given set to its basic or simplest form? In other words, if you are given a set, how can we simplify the set completely? That's also simplifying a hot. How to simplify sets or how to simplify hot sets or simplification of hot sets, or we can say that simplifying hot sets. Okay, so let us before that let us know this. We are supposed to let us know the following. Say that the following are called perfect squares. They are perfect squares. I mean, these numbers are perfect squares. So perfect squares are just the numbers obtained by squaring the counting numbers. I mean, so 1 squared, what do we get? 1 squared, we get what? 1. 2 squared, we get the same as 2 times, we get 4. 3 squared, 3 times 3, which is 9. 4 squared, which means that 4 times 4, which was 16. 5 squared, which means that 5 times 5, which is what? 25. And 6 squared, which means that was 6 times 3, which was 36. So we are saying that these numbers are called perfect squares. Hence, square root of the perfect squares is what? Is always a whole number. So if you find the square root of any perfect square, you get what? You get a whole number. So for example, if square root of 1 is what? 1. Square root of 1. The square root of 4 is what? Is 2. Why? Because square root of 4 is the same as what? It's equal to square root of 4, 2 what? 2 squared. And then we said that 2 raise the square root means raise the power half. So this means that 2 raise the power 2, 2 squared, or raise the power half. So this raise the power half is the square root sign. So this will multiply, you get 2, 2, then 2 times 1 over 2, you get 2 over 2. So 2 over 2 is 1, you get 2 raise the power 1, which is what? 2. So yes, so that's what. So it means that if for any perfect square, if you find the square root of any perfect square, you get what? You get a whole number. Yes, so square root of 9 is what? 3. Square root of 16 is 4. Square root of 25 is what? 5. Square root of 36, and so on and so forth. Okay. So we are saying that therefore, if the set, so if you are giving a set, giving this set square root of what? Square root of y. If you are giving this set square root of y, then we are saying that this set is what? This set, if this set is such that it cannot be what? Be reduced further or simplified further. It is such that square root of y cannot what? This set cannot be simplified further or reduced further. Then this set square root of y is said to be what? Be in what? In its simplest or basic form. In other words, then this set square root of y is said to be what? Simplified. It's said to be simplified. So that's what we mean by what? Simplifying what? Set, or simplification of set, or reducing a set to its basic form, or is what? Its simplest form. So thank you for watching, and see you in the next video. Hello guys, welcome back. Get understanding. Don't remember that that's continuation of simplifying or sets, or simplification of what? Or sets, or how to simplify what? Sets, or reduction of sets to what? To its, or to be to their basic form, or to their simplest form. This is the continuation. So we are saying that the previous video we were saying that if what? You are given a set square root of y, if this set is what? Is simplified, or is what? Is reduced completely, then we are saying that what? We can no more what? We cannot simplify this further. If you are given a set and the set cannot be simplified further or reduced further, then we are saying that what? The set is what? Is simplified, completely simplified, or reduced to its basic form, or its simplest form. So what does it mean? So this is a further explanation. Then we are saying that if that is the case, then this y, this y, mean that then this means that y is what? Contains no factor, which is what? Which is a perfect square. And it means that y contains no factor, which is what? A perfect square. So know that this y is what? Is a rational number. This y is a positive integer. Have you seen? Yes. So whenever you are given a set to simplify, always we look for perfect squares that are factors of the number that is under the square root sign. That is the clue. Whenever you are factoring, whenever you are simplifying sets, that's what you look for. You look for a factor of the number under the square root sign, which is what? A perfect square, so that perfect square can come out of the square root sign, so that it will be the set giving set will be simplified completely. So we are saying that, for example, square root of 5, this square root of 5 is what? Is in this basic form, or in this simplest form. In other words, this square root of 5 is simplified completely. Why? Because this 5 does not contain any number, which is what? A perfect square. We cannot, so it means that square root of 5, this set cannot be simplified further. So we are saying that, and cannot reduce or simplify further, because what? 5 has no factor, which is what? Which is a perfect square. Okay. Also, square root of 15 and square root of 6, all these are what? They are all simplified completely. They are all in their simplest or basic form. They are simplified. Why? Because this 15 has no factor, which is what? A perfect square. In the same way, 6 has no factor, which is what? A perfect square. Yes. Note however, that square root of 20 is not what? It's not simplified. It's not simplified, or it's not in its basic or simplest form. Why? Why? Why is it not in its simplest or basic form? Because square root of what? Because what? 20 has a factor, which is what? Which is a perfect square. So we are saying that, note however, that square root of 20 is not in its basic form or simplest form. In other words, square root of 20 is what? This set is not simplified, because 20 has what? A factor, which is what? A perfect square, which is what? 4 in this case. Because 20 is equal to what? 20 is equal to what? 4 times 5. 4 times 5. So if you have square root of 20, the same as what? Square root of 4 times 5. So since this 20 contains a factor, which is what? a perfect square, which is 4 specifically, or in this case, you are saying that this set is not what simplified completely. Hence, square root of 20 can be reduced as what, or can be simplified as what? As I said, 20 is the same as what? 4 times what? So as I said, whenever you are given a set to simplify, always the number under the square root sign, you have to look for factors that are what perfect square. Factors of that number that are what perfect square. So 20, what number what number that is what perfect square can we find, which is what is a factor of 20? 4. 4 times 5, we have 2 times 10, which is 20, but 2 and 10, none of them is what is a perfect square. But so 4 times 5, 4 is what a perfect square. So it means that square root of 20 is the same as what square root of 4 times what 5. And then so this is what that we begin to what apply the properties, or the rules, or the laws. So if you have this, you can separate them. I've seen them. You put this 4 under its own square root sign, and put the 5, separate them, as we learned from the previous video when we were considering the properties and then the or rules of sets. Yes. So it means that then this square root of 4 is what you get 2, and square root of 5 is say what? It's still 5. Have you seen? Square root of 5 is still 5. Then you get what? 2 times square root of what? 5, which is what? 2 root 5. So 2 root 5 means 2 is multiplying square root of what? 5. In the same way, square root of 50 is what? Is this set is not simplified. Why? Because 50 has a factor, which is what? A perfect square. What is that factor? The factor is what? 25. 50 has a factor specifically 25, which is what? A perfect square. So 25 times 2 will give us what? 5 times 10 is what? 50, but 5 is not a perfect square. 10 is also not a perfect square. So we take what? 25 times 2, which is what? Well, 25 is what? A perfect square. So we separate them as what? 25 times what? Square root of 25 times square root of 2. What is square root of 5? Perfect square. 5 times 5 is what? 25. 5 square. So we get what? 5. And then square root of 2, which is what? Reduce or simplify completely. So we get 5 times square root of 2, which is what? 5 what? 5 root 2. So guys, I hope you are following, you are enjoying. This is not difficult at all. In fact, said you have it at your fingertips. You're going to have this set at your fingertips. You're going to enjoy. So thank you for watching, and see you in the next video. Don't forget to subscribe to the channel. Don't forget to like, share, and click the bell notification icon, so that when further videos are uploaded, you get notified. Thank you, and see you in the next video.